Hey, what's up guys? In this video, I'm going to show you guys how to find the probability of a random variable, and not just any random variable. It's going to be a binomial random variable. And this is using the graphing calculator TI-84. So let's look at the probability distribution that I have here. So this table represents the number of correct questions you guys can get in a 5-question quiz. So the number of correct, you can get 0 correct, 1 or 2 or 3 or 4, or all the questions correct. So we are missing one of the probabilities, and since it is a binomial distribution or a binomial random variable, to find a specific probability, we can use the function binomcdf in your graphing calculator. So I will find the probability that x equals 4. So in your calculator, you guys are going to use your binomial PDF, and P is when you guys are looking for a specific probability. So exactly 4. So I want to find out what this probability is when x equals 4. So the notation is very important, and this is PDF because you guys are looking for a specific one. So I'll show you guys that in a second where you can find it in your graphing calculator. But when you guys write down what you guys use for binomial PDF, you have to label what numbers you guys use. First, we need the number of trials or the number of questions we have on the quiz. So that's going to be n. So we have 5 questions. Then we need the probability of success. And since let's say this quiz is a multiple choice quiz, and you guys have 4 options, A through D, A, B, C, D. So the probability of getting the correct answer in any of the questions is 0.25. So that's one option correct out of 4. So 1 over 4 is 25%. And we want the probability when x equals exactly 4. So I'm going to put 4 right here. So that's going to be your PDF. You guys are looking for exactly 4. So to find that probability in the graphing calculator, you guys have to press the blue button, second bars. You guys need to go down where it says binomial PDF. So we do have 2 options, and you guys have to be careful. Right now, I'll show you guys PDF, and after this, I'll show you guys what the binomial CDF is. But let's do the PDF. So you guys choose. Trials is n. So how many trials, how many questions we have? We have 5. P is the probability of success. So we have 0.25 probability of success. And your x value, well, what probability do we want to find? We want to find out when x equals 4, when the random variable is 4. You guys paste, and your probability, you guys can round to 4 decimal places, 0.0146. So the missing probability in this table when x equals 4 is 0.0146. Okay, so that's one way you guys can find that probability. Another way is, well, we know the sum of all the probabilities in a probability distribution is equal to 1. So if you guys would have add all of these probabilities, the 0, 1, 2, 3, and the 5, and subtract from 1, you guys will get this probability. But the binomial PDF works when you don't have any of the probabilities, and you can find each one of them. If it is a binomial distribution, you can use PDF to find each probability for the random variables. Now let's change it to binomial CDF. Okay, so let's say that I want to find out what's the probability that the random variable x is less than or equal to let's say 4. Okay, so I want to know not exactly 4, but I want to know what's the probability of getting 0 correct, that's less than 4, or 1, that's less than 4, or 2, that's less than 4, or 3, that's less than 4, or 4, that's equal to 4. So all of these options are less than or equal to 4. Okay, so this here, when you guys are looking for different probabilities, and the word or in probability means you add. So what's the probability of getting 0 or 1 or 2 or 3 or 4? You guys have to add. So we are going to use the binomial CDF, and C stands for cumulative, which means you guys are adding. So binomial, and we use CDF. Again, C, you guys are adding, you guys are looking for the community. Now here's the thing with CDF, binomial CDF. The binomial CDF, the calculator will add the probabilities, but the TI-84 graphing calculator, it will add from 0 to whatever X value you guys stop, okay? So what I'm saying is, it's gonna add the probability from 0 all the way to whatever X value you guys want to find, okay? So I want X is less than or equal to 4, so from 0 all the way to 4. So binomial CDF is always adding from 0, it will start at 0 all the time to the X value that you guys want. Now, in your graphing calculator, CDF is very similar to the setup of PDF, so we have to be careful. Your number of trials, it will be the same thing. We have 5 questions. Your probability of success, it will be the same thing. It will be 0.25. But your X value, well, you are telling the calculator where to stop. So I want the calculator to add from 0 to, in this case, I want to stop at 4. So I put 4 right here. So notice the setup is very, very similar, PDF and CDF. So we always have to be careful when we choose one of these. But this CDF is adding from 0 to X equals 4. So when you guys go to your graphing calculator, you guys go to second bars, we go down to binomial CDF, and always double check you are choosing the correct one. The number of trials is how many questions we have. So we have 5 questions. Probability of success is 0.25. And your X, well, when do we want to stop? We want to stop at 4. And the probability will be 0.9990, okay? So this probability, I'm just going to put equals right here. It's going to equal 0.999. So the probability from 0 to 4, a 0 or a 1 or a 2 or a 3 or a 4, it will be 0.9990. You can use this function CDF when you guys want to find any sum from 0 to a specific number. So you guys can add from 0 to 2, so your X value will be 2. You guys can add from 0 to 4, from 0 to 3. You guys can add from 0 to 5. You guys can add 0 to 1, but it's the same way as if you guys are adding these probabilities. It's just the calculators, and it's doing everything for you. So this is how you guys use binomial PDF and binomial CDF. But I do want to emphasize, you guys use those functions in your calculator when you know that the distribution is a binomial distribution. The random variable, it is a binomial random variable. And just to review, you guys can check bins to see if it's a binomial random variable. It has to be binary, so you must have success or failure. Every trial must be independent, so one doesn't affect the other one. The number of trials has to be fixed, so it has to stop somewhere. So this one, the number of questions stops at 5. And you must have the probability of success for all the trials. So every single random variable has the same probability of success. Alright guys, if you like my videos, you guys can subscribe to my channel, click that like button, and I'll see you guys later.